This is Mrs. Lee. We're going to be talking about Algebra 1 M1, so the Module 1 Topic 1 review. I'm going to be going over all of the problems in this packet. Again, if you don't want to use, if you don't want to see the first couple of them because you're like, oh, I already know how to do these, then just skip forward, go to the problem that you need. I'm going to do it in chronological order. So like let's see here, number 11 would be further down the video than it is number 1. Okay, so just skip to where you need to. I would definitely pause first and then try the problem first and then press play, hear the explanation, see if you agree. If you're still confused, you can listen to it again or talk to your teacher about the question. All right, first one. Always read the instructions here, so the directions. So determine the independent and dependent quantities. Don't forget the units. So Benjamin, for number 1, works at a printing company. He is making t-shirts for a high school volleyball team. So the press he runs can imprint 3 t-shirts per minute, 3 t-shirts per minute with the school's mascot. All right, so what is the independent, what is the dependent? So we know we're talking about minutes. So usually when you see some kind of time here, we know that we're going to be talking about the what is it called? That is the independent quantity. So time in minutes. I usually do it as a graph because it makes more sense to me. So, and if you're like, I'm just going to write it out, go for it. So the time in minutes, and this is going to be the number of t-shirts. All right. So again, my independent is going to be my time. So this right here is independent. And my dependent, because how many t-shirts am I going to make depends on how much time we've been running, how long we've been running the press, right? The printing press. So this is going to be the dependent. So just to be very clear, my independent quantity is time. And again, it says units. Don't forget the units. So time in minutes. And it'll always state that for you. Time in minutes. And then the dependent quantity. I'm going to just abbreviate that. Is going to be the number of t-shirts. You don't need t-shirts. So you don't need units because the units is the t-shirts, right? It's the number of t-shirts. So technically no units are needed. If it was something like temperature, then you would need units because are we talking about Fahrenheit? Are we talking about Celsius? Like those are things that you would need. All right, so let's go to number 2. Jose prefers to walk to work when the weather is nice. He walks the 1.5 miles to work at a speed of about 3 miles per hour. So again, what are we thinking about? I'm going to do a little one here. So this one is going to be the time. So a lot of times it's going to be the time. Anytime you see kind of like hours or minutes or any kind of time reference, most likely the independent is going to be your time. And then your dependent, well, it's going to be the miles, right? So this is going to be miles. Technically, we don't say miles. That's the units. We would say distance. So we'll write that out. So again, my independent, so I'm going to be my independent quantity is going to be, oh, not equals, I'll go like this. It's going to be time. And what are the units? Yes. All right, so that's going to be hours. That's going to be hours because we got hours here. And then the dependent quantity, that's going to be, okay, what is miles talking about? Miles is talking about distance, right? So it's going to be distance. And that's going to be in miles. The abbreviated version is MI. Don't just put M because M means meter. MI means miles. Okay? There we go. And that's your independent dependent quantity with your units included. Okay, so make sure you're including those units as well because we want to know what are the units we're using. Because if I just say distance, well, am I measuring it in centimeters, meters, miles? You know, what's it going to be, right? And same thing with time. Am I measuring in hours, minutes, days, weeks? I don't know. You got to specify that. All right, so we're going to do a little more practice on that. It says, label the correct graph with the independent and dependent quantities and the appropriate units. Identify and explain the y-intercept. All right, so it's basically what we're doing in 1 and 2, except we're adding on a little bit more. So, Madison enjoys bicycling for exercise. Each Saturday she bikes a course she has mapped out around Federal Way. She averages a speed of 12 miles per hour on her journey. All right, so what are we talking about here? So we're talking about, okay, so she's bicycling, right, around a course. So is she going to be increasing her distance or decreasing her distance? So it seems like she's starting at home or starting her course, and then she's going to be increasing her distance, right? She's going further and further on her course that's mapped out, right? So then what is the independent? The independent is always here, like I said for number 1. So this is going to be the time. So did you see the time reference in there? If you didn't, go back and look. So we're like time. Yeah, we got hour, right? So we got time in hours. And then we have 12 miles, right? Because this is her journey, right? So this is going to be distance. You don't need to be specific. You're not going to see numbers here. You're not going to say like 12 miles per hour. That doesn't work like that. Okay, so it's just going to be distance, and then this is going to be in miles, right? So she's going 12 miles per hour. So if when 1 hour passes, that means that 12 miles she's gone 12 miles. Another hour passes, and she's got another 12 miles. This is probably not an hour. Those would be very, very tiny. All right. So that's what that's going to look like. And then if you want, also if you want to be a little more specific, you can say distance biked, but distance is okay too. Let's see here. We need to indicate, it says label the correct graph with the independent dependent quantities, and we've got the units. Oh, and it says identify and explain the y-intercept. So we'll make the y-intercept blue. The y-intercept is where, remember, y-intercept is a point. Okay, so y-intercept is a point, is not the y-axis. A lot of people are like, oh, the y-intercept is the y-axis. That is incorrect. So this is the y-intercept. So do you see how this graph crosses that y-axis right here at 0, 0? So in this case, the y-intercept is 0, 0. So the way we interpret that is, or explain it, is we have to explain each 0. So what does the first 0 mean? Remember, the first 0 is talking about time. So this is actually 0 minutes, and that is 0 miles, right? Because the y is talking about the miles. So what is happening at 0 minutes? So at 0 minutes, so when does 0 minutes happen? At the start, right? At the start of her journey. So at the start of Madison's course, she has traveled or biked, if you want to say, 0 miles, right? Which makes sense, because if she hasn't gone, if no time has passed, this is the very beginning, how much does she, like somebody stops her at the very beginning before she just goes, how much has she traveled? She has not traveled any miles, right? It's just 0. All right, so that's how that goes. This is the interpretation of that, okay? So make sure you're writing down the point, and then you're writing down the explanation. And so if you notice right here, where is the 0 minutes? Because I only see 1 0 here, right? So the 0 that's represented here is at the start. Okay, it's at the very beginning. If you want to say when, you can say when 0 minutes have passed, you can say that, but it's just, nobody really talks like that, you know what I mean? Let me go with my orange. Okay. Sorry, my arm is in the way. So the 0 miles right here is talking about this part right here. So these are related. So this is how you see the numbers in your sentence. All right, let's try number 4. Dun, dun, dun. So Jermaine is saving money to purchase a used car. He places $850 in a savings account that earns 1.65 interest annually. I will say anytime you see something about interest, right? If we're talking about interest here, you're thinking exponential. And remember in class we talked about an exponential graph. It's gonna like start slow and then kind of go up faster and faster. That's what that's gonna be like. All right, so here we go. Again, I saw some kind of time reference. So where do you see the time reference? He places $850 in a savings account that earns 1.65% interest annually. What does annually means? That means once a year, right? This means once a year, right? So we're talking about time here, so here's time. And annually means years, so we're going to be in years, all right? And what are we measuring, right? That's going to be our money, right? So this is going to be amount saved. And that's what are we saving in? What is Jermaine saving in? In dollars, right? Because, you know, not everywhere in the world uses dollar bills, right? So I always like to put the units in parentheses so we know that's what we're measuring it in. If you want to write out dollars, you can do that, but why do that when you could do this, right? So we are definitely in dollars here. So those are our, we've labeled our axes. And we're going to talk about the y-intercept. The y-intercept is right. Again, this is where the line crosses the y-axis at this point. So this is, again, the y-intercept. I usually shorthand it and say y-int, so just, you know, just to let you know. And what does that y-intercept mean? Well, first of all, let's find out what the point is. So it's going to be at 0. And then how much did we go up from there? It's going to be 850, because that's how much we're starting with, right? A lot of people will catch on to that, but they don't realize that that's this point right here, right? And then, so what does that mean? Remember, this means right here, this is the time, so this is years, and this is in dollars, right? So what is this 0 years? That's like at the beginning, right? So at the beginning, at the start, should we do at the start? At the start, or at the beginning? Would beginning make more sense? It is up to you. You do you, right? Write a better sentence than I will. At the start, Jermaine saves $850. Ooh, I found a better word. I thought of a better word. Instead of at the start, I thought initially, right? Doesn't that sound very initially? Jermaine saves $850. Done. All right, so where are you seeing that the 0 years, right? So the 0 years is represented by the word initially, because that means at the start, right? And then $850, that one's a little more obvious to see, right? Because that's how much we're stating that he is saving. All right, so we got all of that in there. We have one more that is similar to this. Now we have Chloe, who is using a pump to drain her backyard pool to get ready for winter. Yeah, can't have that full during the winter time. The pump removes the water at an average rate of 15 gallons per minute, right? Again, I'm hearing time. You hear the time as well. So we do know that there's some kind of time going on here. Okay, so it says we're draining. So are we going to be increasing in water or decreasing in water? Sounds like it's a pretty simple one, and we are definitely decreasing, so it's going to be the B. So the time is passing by, and we're going by, what are the units? Minutes. And honestly, if you have not paused yet and you've just been watching me, that is good. While it's good, it's not beneficial to your brain. So I would definitely go back and then try some of these yourself without looking at the video, and then just try doing it yourself. And if you need a new copy of this packet, please let me know, or your teacher, yes? All right, so there's time, and then what are we measuring here? Oh yeah, did you say the water? I think I vaguely heard you. So that's going to be, like, we're talking about gallons, right? Not the 15 part, but, so, gallons, so this is, remember it's going down, so it's the amount of water that we drain or the amount of water that we have left. So since it's going down, it's the amount of water left. and then that's the one amount of water left in the pool. So let me say in the pool. So that's going to be, again, we got gallons, so gallons. All right. Now, where is our y-intercept? That point right there, this point is the y-intercept. What number is that, though? So honestly, it's 0. We know it's 0, but do we have 15 gallons in the pool? It's a very small pool. Then it's a pool for like little dolls, right? So we know that the average rate of that the water's leaving the pool is 15 gallons per minute. However, we don't know what it starts with, so we're not sure about what this is. We don't know how high that is, right? How high the water is, so it doesn't tell us, but we can still interpret it. We just won't have like specific numbers for that. We just know is that at the start, because remember this is in minutes, at 0 minutes, that's going to be in gallons. No, we know that we're going to have a full pool, right? So I'm going to say before Chloe, because technically she hasn't started yet, right? Because that's 0 minutes. No minutes have passed. Before Chloe drains the water, there is, what should we call that? I know in the answer key there is a number there, but, and they say 240, but there's some calculations that are going on because we know that, but we're not going to go there. It's the amount of water that's in the pool before Chloe drains the water. So, you know what? I'm going to just change the sentence. It's going to be the amount of water in the pool before Chloe drains the water. Haha. That's how we're going to figure that out. There we go. Happy days. Right? Because we don't know. Technically, we don't have enough information just from here. We won't go there. I guess we could start labeling these, but that is above what we need to do right now. Alrighties? All right, so there's number 5. Oh, we didn't do the things. So where do you see the 0 minutes? That's going to be before Chloe drains the water. That's the word before, right? This is in context. And then the question mark guy. So this, because we don't know, but it's the amount of water in the pool. That's where that is located. All right, number 6. It says determine if the relation is a function or not a function. Explain your reasoning. All right, so we have this curvy looking graph right here. And if you guys remember, whenever you have a graph, it's a very simple thing to do because in general, for it to be a function, the whole idea is the definition of a function is that every input has exactly or only one output. Instead of an input, you want to put in like x. For every x has exactly one y. You can say it that way as well. If you look at this right here, right? If you look at so if this is 20 and halfway in between, this is 10, right? So at 10, what is the value of y? Well, if you look at the graph, there's this point right here. It is whatever that's going to be. So like if that's about 10, this is about, they're going by 2, so about 2.6, I don't know, whatever that is, right? So there is one value for x here. If you look at like this point right here, this is at 16. If you look at this line, where is x going to be? Oh, it's right here. Oh, where's the point going to be? It's right here, which means there's only one y value, right? So this is what we call the vertical line test. And the vertical line test is because we're looking for all the x values, right? At every x value, is there only one y, right? So basically, is there only one point for every x, right? And if you look right there, there's nowhere on here where this line will, like this, the graph will cross this vertical line more than once, right? It's only just once every single time, right? So the way we say it, so this is a function because, because honestly for graphs we can just say because it passes the vertical line test. That's the vertical line test. Remember the test that we did with the vertical line like this? All right, so number 7, it's another graph. Does it pass the vertical line test? And you're like, yep, so far so good. And I'm sure a lot of you guys, your eyes just automatically went to the little loop right there and you're like, that's not good. Because how many times does it cross right here? Like 3 times. Sad days. Like right here. 1, 2, 3, right? Crosses 3 times. Anything more than once and is not a function, right? So this one is not a function. Because it does not pass the vertical line test. Okay, I'm going to just say the VLT, if you guys don't mind. All right, it does not pass the vertical line test. Fails it right here. Even at one point, any one point, it crosses like twice. It fails. The whole thing is not a function. Okay. All right, let's go with 8. Is this a function or not a function? Remember, for every input, there is one output. So 1 goes to 2. I'll put a little arrow there. Excuse me. Excuse me. Oh my. I was sneezing in pairs. I don't know why. Are you like that too? All right. And so this 3 goes to 4, right? But if you guys notice, 2, that's a lot of people look at that 1 and you're like, does that work? Because two numbers are going to it. But the question is this, does every input, the focus is on the input, not the output, does every input, so this is 2, go to one number? Yeah, 2 goes to 1. Does 0 go to one number? It goes to -2 and 1. We can't have that. This guy right here, this guy's the problem. Bad days. 0 can go to -2, goes to 1. Don't want that, right? So we say this is not a function. Please don't say it does not pass the vertical line test. We're not doing that here, right? This is not a graph. Not a function because 0, I like to give the example why, or the reason why. 0 has 2 different outputs. If you want to list what those outputs are, you can, but for me, this is what I usually do. Because 0 has 2 different outputs. Done. That's my reasoning, not a function. All right, so number 9. We're going to do the same thing. So I'm going to look, usually the easy way to do it is look to see if all the x's, are they all different? And I'm like, okay, 3, 8, because honestly, if they're all different, it doesn't matter what they go to. Every input is one output, right? But if you notice right here, we got this 3 and we got this 3. Those are my 2 x's that are the same. So you're like, that's like a warning sign. I got to check. I'm not saying that it's not a function. I just got to check another condition here. So I just got to say, is it still pointing to the same number? So here, my input is 3, my output is 1. Here, my input is 3, my output is still 1. So that's okay, because I put in, 3 is still pointing to just one number. It's not, it just came out twice. It's just still pointing to one number, so it doesn't matter. So yes, this is a function, because, sounds familiar, every input, or in this case, if you want to say x, has only or exactly one output. Because even though this came out twice, it's still pointing to the same thing if you want to think about a mapping like this. All right, number 10. All right, let's take a look here. We got 3, no other 3s. Oh, we got 2. So we got doubles right here. And we got 1s coming out again, right? So we got to check this. The 0 is fine because 0 only comes out once. But 2, if we put in a 2, we get out a 3. But here, if I put in a 2, we get out a 7. Ooh, bad case. Okay, this is no good. It's already not a function. But I'm just going to check the 1s just, because I'm thorough, right? And if you look at this, 1 goes to 4 and 1 goes to 6. Do you see how they're 2 different points? Can't have that either. So this is also a problem. Not a good day. All right, so this is not a function for days. So not a function because I'm gonna just call it out. I'm gonna call both of them out because I don't want to choose, right? Because 1 and 2 both have 2 different outputs. Done. All right, so there was function, not a function. And then now we're going to do the domain and range. All right, so here we go. We've got domain, range, and intervals increase, decrease, and constant. So I'm going to do my pink color for domain and my yellow color. Let's see if yellow comes out on here. My yellow color, yeah, that kind of works. Yellow color for range. And we'll talk about increase, decrease, and constant in a bit. So we'll do domain and range. Well, we'll do domain and range first, and then we'll do the intervals. So domain, remember, talks about the x values, right? So what are all the x values in this graph? So how far left does it go? It goes all the way to right here. So this is at -6. And goes all the way to, boom, +6. So from -6 to +6. And the way we write that, we got domain here. So it's going to be from -6 to +6. Right? I intentionally put spaces in there because remember the domain refers to the x. And so since -6 is less than +6, I'm going to put these less than symbols in there. All right? So that's what that's for. And we know that x is somewhere in between. X can be anything in between -6 and 6. The question is, can x be -6? So if we go here on the graph, we go to -6. Can the graph equal -6? And you're like, yeah, because it's a closed circle. So I'm going to just put an underline underneath that. What that underline is basically an equal sign. So if an equal sign and a less than sign, if they fuse together, oh, that looks like a sad face. If they fuse together, this would turn into, just put an arrow there, that turns into a less than or equal to sign. Okay, so that they're combined together like this. Okay, and the same thing with 6 over here on the right. And we go over to 6, and you're like, yes, that could equal 6 as well. So it's going to be -6 is less than or equal to x, which is less than or equal to 6. Smaller number always comes on the left. So that's what we're always going to be dealing with less than symbols here. All right, now we're going to talk about range. Range is talking about the y that you can't see. So I'm like, y. All right. So how low does this go? So it goes all the way down to 0. Don't say 3 because we're looking at the y here. All the way up to 6 right up here. Right? Do you see within this box right here, it's staying within here, right? It's not going below 0, right? So if you want to look at it like that, so it doesn't go anything below 0. So it's just right up here. That's as low as it's going to go. All right, so we're going to write it like this. So here's the range. We're going to say 0 is less than or equal to y, which is less than or equal to 6. Right, because now remember we're talking about the y now. And then we're going to talk about the increase and decrease. And remember, we're always going left to right. So these guys, let me use the purple color here. So these guys right here are always going left to right. Okay, that's how we determine that. So I'm going to say, well, let's do it a little bit backwards. So increase, I'm going to make purple. And we'll make green, or no, let's make this aqua color. It's going to be decrease. All right, and constant is going to be this yellowish color. Oh, I should have made this it. This is constant. All right, so increasing. Where does it increase? So again, from left to right, this is going down. This is going up right here. This is increase. So this is from -3 to 0, right? So I'm just going to write -3 to 0. All right, when else does it increase? From 3, right here, 3 to 6. So from 3 to 6. These are the intervals that's increasing. Right there. Okay, and then so when we're talking about decreasing, we're going smaller, right? So we're going down this way, right? So this is decreasing from -6 to -3. So -6 to -3. And then decreasing also over here from 0 to 3. All right, so that's how we determine that. Notice that we don't have anything that's constant, right? So if it's not constant, there's nothing there. Okay, it doesn't. You don't have to have all three. All right, let's go to 12, and we're going to talk about the domain. So the domain is going to be, well, how far left does this go? Well, do you see this arrow right here? What does that arrow mean? It's going to go forever. That means it's going to go forever to the left. So how far left can you go to forever? That's going to be -infinity, right? Because it goes all, -infinity just means it goes all the way to the left and never ever stops. And then notice on the right hand side, we have another arrow here, which means it goes to the right forever and ever and it never stops. So from -infinity to +infinity, right? And we know that x is going to be anywhere in between that. Again, we're using those less than symbols. We're not using equal signs here ever, just because technically, by definition, you can't reach infinity, right? You can't reach -infinity, right? Because it's always bigger than the bigger number, or the smaller than the smallest number, right? So that's, or smallest than the most negative number, right? It's just, that's what, by definition, that's what it is. So there's the domain. Well, then what about the range? How low and how high does it go? It's going down, right? So it's going down forever, and it's going up forever. It's the same idea, right? So this is going to be the range is from, again, -infinity. Just don't forget to put in the y now, to +infinity. And this is always going to be decreasing. It's always going down. So I'm going to be like decrease from -infinity to +infinity. It's always decreasing because remember, we're always going from left to right. So it's always decreasing. All right, and then so we got 13. Domain is going to be our pink right here. So how far left? From -2 all the way to +5. Right, so that's going to be domain from -2. It can equal it because there's a point there, so less than or equal to x. And then, oh, this is an open circle, which means not equal to. That's a whole basically. Whole basically. So it's going to be less than 5. Okay, so from -2 to 5. It could be -2, it just can't be at 5. Because what happens when you get to 5? If you were like walking on here, you would fall into the hole, into a never-ending pit. Sad days. All right, and then we're going to go to the range. How low does it go? All the way from -3 all the way up to 1. So we're going to go from, range is going to be from -3. It can be -3. So that's, we got the equal to sign, all the way up to 1. Again, for the same reason, it cannot be equal to 1. There we go. And this is always from left to right, so it is always going to be increasing. Well, not always, but it is increasing. from -2 to 5. That's the interval in which it's increasing. All right, last one. Here we go. So we have the domain here. How far left does this go? All the way from 0, see the 0 right here, all the way to 16, from 0 to 16. So domain 0 less than or equal to x, which is less than or equal to 16. Our range is going to be from, how low does it go? Oh, this is the lowest point right here, right? See this point right here? So that's 3. It goes all the way up to 15 right there. So this is how low it goes, all the way up to 15. So our range is from 3 less than or equal to y, which is less than or equal to 15. Right? Remember, it's not how low that the y-axis goes, and how low that the graph goes. And the graph goes as low as 3. All right, and we are doing all the things here. So we are, first we are decreasing, right? So decrease from where? Starting from 0 all the way up to 8. From 0 to 8, we are decreasing. Then what are we doing? See how we're going like straight across? Right, this is straight across, so this is constant. Because it does not go up or down, it's just going straight across, right? So that's going from 8 to 11. And then we're going to be increasing, because we're slightly increasing. Increase, and that's going to be from 11 to 16. All right, so we got all the sections. I was wondering if we're going to get a constant one. There it is. All right, number 15. Graph a function that is linear, continuous, and increasing. So linear means a line. So we're going to draw a line. And it's continuous, which means we're going to draw one continuous line with no, like, we're just not going to do distinct points. And increasing means we're going to go up this way. So it'll just be like, boom. And to wait, show it's just going to put arrows in there because we show that it goes on for all, because linear. All right, I guess you could do a line segment as well. I just like to do it this way. So here's increasing, continuous, and linear. Linear, discrete, and constant. Okay, ooh. We know linear, but it's discrete, which means we want distinct points, and constant means we're going straight across. So you can pick any of these lines right here. I'm going to pick this one right here, and I'm just going to go straight across. Technically, it can be like that, because it's still linear, and it's discrete, and it's constant. Like, I'm not moving up or down. It's just going straight across. You could have done that up here. If you want to do all the little intersections, you can do that as well. That works too. Okie dokes. All right, last one. This one's a little bit different because you can write any kind of story, right? But it's not just any story. You have to really read these axes, okay? So it says, write a story to match the graph. Make sure to use the given quantities in your story. Choose appropriate units and label the scale on the x and y axes, right? So first of all, we're not going to be like, oh, I'm going to talk about money. I mean, you could, but if you look right over here, that's not relevant because it says distance from car, right? So the distance from car, I don't want to be that far away. So I'm going to be like distance from car in feet. All right. I'm not going to do miles because I'm not walking miles to my car. That would be sad days. And then this is going to be time in seconds because, you know, it doesn't take, I don't imagine I'm going to be that far from the car. So I'm going to go I'm going to just go every 1 foot. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8. Just don't think too complicated on here, because if you do, it's just going to it's just going to take a long time. We'll just make things work. 5, 6, 7, 8, 9, 10. Okay. That's 9. That's going to be 11 down there, right? I didn't want to go over the x. So remember, we're looking at distance from car. So how far am I at the beginning? I'm going to be 8 feet away from my car. So I'm getting really close to my car. So I would say like let's write it here. I start out 8 feet from my car. Okay, I'm explaining that point right there. That's a good place to start. And then I'm going to be talking about this place right here. What am I, this part right here, right? I'm going to call that my number 1. This is like my y-intercept right there. So that's like my, how I set my stage, how I set the stage. So what am I doing here? I'm getting closer to my car, right? So I walk towards my car. I walk how many feet? I was from 8 feet all the way to 4 feet, so I walk 4 feet because this distance right here is 4 feet. I walk 4 feet towards my car because I'm not at my car yet because I'm still 4 feet away from my car, right? So I walk 4 feet towards my car in how many? In 3 seconds. All right, now we're going to talk about this guy right here. So I'm going to mark that number 2. So what's going on here? I'm not getting closer or further away from my car. I'm just staying there. So why would I just stay there? Oh, because I thought I forgot something. I stopped because I stopped, right? I'm not changing my distance, right? I stopped because I thought I forgot my keys. Yeah, just make it something simple, right? I stopped for 1 second. I'm just going to include that for 1 second. How do I know it's 1 second? Because it's between time 3 and 4, right? So that's 1 second. 1 second has elapsed. And then we're going to go, let's go blue now. So now we're going to talk about this one. I continue, right, to walk to my car and get there in how many seconds? And it started before the 4th second. So 1, 2, 3. So in 3 seconds, I got there in 3 seconds. Remember, I did stop, so its time was still going on. So I get there in 3 seconds. And then let's go with this color. Oh, now I'm all of a sudden like going away from my car, which means I have to explain that, right? So I realized I dropped my keys. So I go back. We go back to get them. There we go. So that explains why I'm leaving the car. Okay, because the distance between me and the car is increasing, which means that I'm going away from my car. Right? So there must be a reason for that. So it's probably because I dropped my keys. Right? So there we go. So that's what is explained. You can do whatever story just as long as it has to do with the distance from your car. Remember here, I'm not talking about speed, right? Because if this was speed in my car, then that would be a different kind of scenario, right? I started at 8 miles per hour, right? Maybe it's not a car, it's a very slow car, right? I'm decreasing in speed, then if this was speed, then I'm maintaining 4 miles per hour for one minute or whatever the units are, right? And then I'm decreasing my speed again until I come to a stop. Then again, I increase my speed. It was a brief stop, right? Split second stop, and then I increase my speed again, right? So speed, if this says speed, it would be different. It would be a completely different story, okay? So you need to make sure you're reading this label right here. All right. I hope that was helpful for you. If you have any questions, please let me know. And see you guys. Good luck on your test. Do well. Okay. Oh.